Cool. Well, welcome everybody. If you're in the right place, you're at the Build and Ship Faster with Developer Optimized Experience on Windows session. My name's Kayla Cinnamon. I'm here with Craig.
Hello, I'm Craig. I'm a product manager working on the Windows subsystem for Linux and other AI tools on Windows.
Oh, cool. And Jinyei as well.
Windows, performance, and you'll hear about that.
Perfect. So our team covers a bunch of your favorite utilities on Windows, obviously Windows itself. And then we have PowerToys on our side, Windows terminals from our team, WinGet, the Windows Package Manager, and WSL, the Windows subsystem for Linux. So today we're going to cover a bunch of updates that have come across these utilities, and we're going to get into it pretty quickly. We have minimal slides because that's our jam. So we're going to cover building on Windows. So that's going to be, when you're building your apps, but it's really the improvements made to Windows that are the things we're going to be talking about. And then also building for Windows. So that's going to be everything we've created to help make building those Windows apps even more seamless and even easier to do. So I think that's it. We're going to get into some desktop stuff right now. So let's hop on over to mine. Sweet. So a lot of this was in the keynote this morning, but we're going to go a little bit deeper into some of these topics. But first up is all about developer setup. So when you're on Windows, you got to go grab all your things, Python, Node, all your packages, all your favorite tooling, and it takes a long time. So our team has actually put together a WinGet configuration file that does a bunch of this stuff for you. So it installs Ubuntu along with Windows Subsystem for Linux, along with tooling like Git, GitHub CLI, Copilot CLI, VS Code, all of those things to make that step a little bit easier. And what's really cool about these WinGet configuration files is that they're idempotent. So if you already had Git, which most of us, I'm sure you do, it's not going to install Git again. It's just going to make sure that Git is there, and then it's going to move on to the next thing. So if you want to get this today, we have a repo that we published this morning. We made public. It's Windows Developer Config. We will also have a slide at the end with all of the links and all the goodness, so no sweat now. But there's a few other things that we're going to show today that are in this repo, but the config file is here, and you can download it and see what it's going to install, and then you can run it and go from there. So that's a quick way to get your developer device set up. And then some things that we've added to Windows itself that are in the Insider program and are shipping is some taskbar personalization, in particular, movable taskbar. So this has been a very popular request. We're excited to bring it back. Here's the taskbar on the left. You can put it on the top, put it on the bottom, where it's always been. But yeah,
nice.
Thank you. So force of habit, I'm going to keep it on the bottom because I'm going to lose my icons if I put it on the left. But this is in the Insider program, and another thing that's coming is the new Run dialog. So very exciting. So this is Run. It looks somewhat similar, but a little bit more streamlined of a UI. And what's really neat about this is that it's built leveraging the architecture of PowerToys Command Palette, which looks like this. So PowerToys had PowerToys Run even before this, which looked even different. Let's see if I got that. So here's the evolution. We have PowerToys Run. This came out first. And then we evolved this into Command Palette, which has a bit more extensibility, more things you can install into it, a different UI based off feedback. And then this architecture is now inside Run. And you can search for your tooling, and it looks very similar to how Command Palette was, maybe just inverted. So what's really great about that is, we're all about open source. That slide I showed at the beginning, I think almost everything on there except Windows is open source. So if you contributed to the Command Palette on PowerToys, there's a good chance that your code is now in Windows, which is very cool. So that was vertical taskbar. We have Run. And now one thing I want to cover, also open source, is an experiment that we are trying out that we want to see how you guys like it. So this is Intelligent Terminal, and it kind of came from, we're working with all these agents, but when you go into Copilot CLI, it takes over your whole terminal. So it would be really nice if you had a companion working with you, so you could still stay in your prompt, but then have an agent helping you along the way. So here's a regex command that I asked an agent to write for me, because I don't know regex, but I also asked it to make it not work. And the agent has detected that it doesn't work. This is meant to be like a password verification regex. And the agent is now thinking about how to fix this, and it should give me a solution to create a better regex. So it's not giving me a command specifically because it doesn't know my desired outcome. Do I want to check for an uppercase letter? Do I want to check for a unique character? So I can work with the agent to come up with a better syntax of regex without having to leave the terminal. And what's really cool is when you first get Intelligent Terminal, it's going to ask you, like, hey, which agent do you want to work with? I only have GitHub Copilot installed because I'm a GitHub Copilot fan. But you can add in Claude, Codex, OpenCode, anything. Once you install it on your machine, it should automatically get picked up by Intelligent Terminal. And you can pick your preferred model as well. So this is available today. We want to get your feedback on this. Like, how does this agentic pane feel when you're working with it? What kind of things do you want to change or have added to the experience? We want to know. So this is open source. It's on GitHub, published, I think, this morning as well. Everything is fresh this morning. So yeah, go ahead and try this out and let us know how you like it. But since we're on the topic of terminal things, I want to hand it over to Craig to show a little bit more.
Yeah, so let's take a look at my machine, and we're going to take a look at WSL containers, also freshly announced this morning, and something we're really excited about. My goal today is to convince you, if you have never used containers before, why you might want to get started using them, and show you how you can do all this with WSL containers. So we've added a new binary to WSL called WSL-C. I can go ahead and run this, and I can run tons of different Linux container commands. So a Linux container is basically just a very nice little package where I can run arbitrary Linux binaries or distributions. In this case, I just ran Ubuntu, right? I ran the latest version of Ubuntu. But if I'm more of a Debian fan, I can very easily just go here and say, hey, give me the latest version of Debian, and then it will be able to go pull it down for me. Even though I didn't have that downloaded, it pulled it down and ran that, so I can run that directly here inside of my terminal. Where containers get really powerful, and where this really shows for WSL container, is you can use this to build powerful Linux environments that you can share to the cloud or locally. And now this all works just directly as part of WSL. On top of that, we have container as an alias that's built in. So you could use either WSL-C or container, whichever is more to your heart's desire. So if I go to this file here, I have a container folder, and in it I have some different container files. And so what I can do is actually build this image. So I'm going to build a service directly inside of my terminal. So it's going to go ahead, grab that image, build it. I actually ran this before, so everything was cached. And if we go ahead and take a look at that container file with edit, great editor tool. If you haven't seen this in the command line, it's beautiful. It works with your mouse, which probably my favorite part. And if I go and take a look at this, I can see I'm grabbing Python 3.13, and then I am going and running a bunch of different Linux commands to set up a specific Linux environment. Now that I've built that container, let's go ahead and take a look at it in my list. So I just ran WSL-C, image-ls, and then I piped it to grep and ran marketdown. Well, hold on. Piping it to grep is pretty cool because we have just released Core Utils, which is a new way to run a ton of different Linux core utilities all directly on Windows. So things like grep are now available as part of that. I can even go ahead and take a look at, I'm looking at that list, and then I pipe this to WC, which counts the word count. It's telling me there's 165 different tools inside of this. So let's take a look at the list. Things like test.exe, tail.exe. I'm personally really excited about env.exe, which shows you your environment variables, because I only really know how to do that in Bash, speaking from personal experience. And it's just a super awesome and powerful way to, if you're a big Linux fan like I am, and you're a big fan of bringing those worlds together, they can just coexist so nicely. And so let's kind of go back to our example, and I am going to run that marketdown service which I built. And so I can go and run that here. And so I took that container that I defined in that container file, and then now I'm starting it up. What you'll notice is that I use this -p to say, please take port 8000 in the container and forward that onto Windows. And so now when I have that and I go to Edge and I go to localhost 8000, I get what that container is. So that container is defining a very neat little web app for me. That web app allows me to go in and take any folder. So let's go and find my samples, which I have very conveniently placed about 30 folders down. Just 29 more. Just 39 more.
Wow,
all right, here we go. So there we go. And then I can drag and drop this in. All this does is it takes any PDF file, or any file in here, like .docx. So it took this complex PDF, and then it converted that into Markdown, and it shows me that on the left and that on the right. So that could be my full website, right? Contained right there. I was able to go run that. And so, if that didn't convince you, I think the last thing I'd really show is you can do things like light your whole terminal on fire by running different containers. So that someone built that you can go run with just one command line, a super powerful tool. And I think it begs the question of why did we build a Linux container CLI and when there are other awesome CLI tools, like there's Podman Desktop, Docker Desktop, Rancher Desktop. And the answer is these are all great tools, but we actually also built an API for this as well. And we're going to be showing that in part 2 on the building for Windows. Right? And so we'll show that. And because we wanted to be opinionated about how this would work, like for example, we added this system session command. This doesn't exist in Docker or Podman. We're being opinionated about making sure that these things, the API and the CLI, can work together. So we knew we were going to make some decisions like that. That's why we created a CLI. But the best part is this is all open source. We have a ton of improvements coming to the underlying virtual machine technology powering this. And those will all go to Docker, Podman, Rancher, all for free. For example, we are improving cross-OS file performance by 2 times when accessing Windows files from Linux. And so something we're really excited for. And that is the whirlwind tour.
Cool.
Let's jump back.
Yeah, well, so actually I pulled this up while you were chatting. The core utils that he showed with all the 75 command line utilities available on GitHub. So if you want to go grab this today and have all those utilities right away, you can come over to this repo and download them from here. And something else, like we're talking about WSL and all that stuff, something else that comes in this Windows developer config is a comfort shell. So this is a customized not flavor, but like a, what would you call it?
It's like a customized implementation of Ubuntu.
There you go.
Right.
What he said.
It's a setup script.
Yeah, so it will come with everything pre-installed that you're familiar with. So if you're someone who likes to use Homebrew or ZSH, Starship, those kinds of tools, we pre-install all of these for you with that comfort shell, and it'll plug right into your Ubuntu distro. So one of my favorites, I showed this at the keynote, but like, how cool is that? It's BTOP. So this comes baked in along with a lot of those other tools. I think that's what we've got for building on Windows. We might want to do a little recap because that was a lot. So let's jump back and kind of walk through the things we showed so far. So we started with optimizing your setup with that config file available in that GitHub repo. That includes a lot of fan favorite tooling. And then there's also that intelligent terminal, which is an experimental experience that we're playing with of how you can have an agent helping you in your terminal. Then there's those Windows improvements, so new run, leveraging the PowerToys Command Palette architecture, along with vertical taskbar, and then we've got those core utils as well. And then, as Craig covered, the WSL container new implementation for having a native container solution that works with your existing container files. And then, of course, Comfort Shell, which we just showed with that cool BTOP thing at the end. So that is building on Windows. Now we're going to talk about building for Windows and how you can streamline building your apps directly on Windows that are like WinUI apps, that sort of thing. So I think it's still me, so I'll keep going. So something that we have come out with that is intended to make building Windows apps a little bit easier is the WinApp CLI. So this is a command line interface, also open source. That's our jam. Everything's on GitHub. It's great. But this is a single CLI for managing Windows SDKs, packaging, generating app identity, manifests, certificates, and build tools. And you can use it to really just jumpstart building all of your Windows apps. And it covers the hard part, like publishing and all that stuff. So it's got, let me see, there was a section that I wanted to show that I am now missing. Oh yeah, here's some things that having package identity for your app unlocks. So this is a really great thing to use if you want to have package identity, but having interactive native notifications along with integration with Explorer, Taskbar, Share Sheet, that kind of thing. And then there's also instructions for how to get started with this as well. And of course, it's on Winget because everything we make goes on Winget, so it's really easy one-line install. And then something that leverages this is the 𝗦𝗽𝗲 skills. So this is an agent plugin, and plugins for agents is really just a bundle of like skills, MCP servers, custom agents, that kind of thing, and then they just called it a plugin, but it's really just all those other things we know in one installer. So this is what you can use with your agents. Oh, there's a talk later. I should go to that. You can use with your agents to build WinUI3 and WinApp SDK apps. So this comes with a lot of skills that are really helpful, like building and running the workflow, having WinUI design, WinUI code review, testing, packaging, migrating from WPF, session report, along with WinUI setup.
What I like about it is it's showing you up-to-date information. Your agent doesn't need to go out and waste tokens on like a web search. It can directly access some of the stuff. That's not older information either.
Yes, totally. So that's a great point. This is a really great way to be more efficient with your token usage. If you already provide that context to your agent, saying, hey, here's the skills, here's how to get all this stuff, rather than researching WinUI3, it's going to know all about it with this plugin. And I installed it by running this long prompt. I just pasted it in Copilot because it's a little bit easier. But you can also do it by hand if that's your jam too. And I think it might be kind of fun to try to build a WinUI app right now. I don't know how long this is going to take, so bear with me. But I liked Craig's Mark It Down app. I think we could try to build it again.
That's okay. You can steal my idea.
Yeah,
That's fine.
All of my ideas are original. What do you mean? So I'm going to jump into Copilot, and then I already have this plugin installed because I ran that long prompt, right? And when you get here, first thing you want to do so that the agent is in the right state is you want to set the agent to the WinUI dev plugin. So after you install it, you're going to get a custom agent. So this is going to know to route to those skills to get all of that WinUI, WinApp SDK goodness too. So we're going to set this. So now here you can see I've got WinUI dev set as my custom agent. So that's how you know you're in the right place. And then I'm going to try to use the voice feature of Copilot CLI. Since I'm on stage and everything, I don't know how this is going to go, but I'm going to just yap to Copilot really quick to build his Mark It Down app. So let's see how this goes. Let's build a native WinUI3 app that takes any file and converts it to Markdown. Have it have a side-by-side view and display the contents of both files on each side of the app. Make it look prettier than Craig's Mark It Down app. And then do UI testing and run it after it's done. Cool. I'm also going to put this into autopilot mode. I just switched modes with Shift-Tab. So you got plan, autopilot, and like regular. And we're just going to kick this off. Enable all permissions. This is fine. Everything's great. It's not like this is my real machine, right?
Yeah. Or it's a live demo or anything.
Right. We don't know what's going to happen. And I don't know if this is going to finish either. But something that comes with those skills and that plugin is the UI testing. So it's going to hopefully build the app, deploy it, and then it's going to do UI testing that comes baked in. So it's already going to know how to do it. And my mouse would be like bouncing around and clicking all the buttons and checking all the text boxes and everything. So I'm going to let this run. I did do this before. I didn't say make it prettier than Craig's. So it's not beautiful. But I did build this WinUI app with that prompt, well, different prompt, but with that plugin to kind of do the same thing. And it worked on the first try, which was awesome.
And what's great is it's using all the modern tools, right? The modern buttons, et cetera.
Right. Like this is truly a WinUI3 component along with the text box and everything and this browse file button and all of that. So, and then, we got to talk about PowerToys too. I'm just shoehorning this in because I love PowerToys, but they just added this new utility. It's grab and move. So, so I have, 50 tabs open on Edge. Don't judge me. I'm one of those many tab people, not many Windows people. So I can never grab the taskbar or the title bar because my tabs are in the way. So grab and move lets you just hold Alt and you can just click from anywhere and you're just dragging the whole thing around. So it makes it a little bit easier, which is awesome. So I'm going to let this run. hopefully it'll build in the next 25 minutes. We're gonna see. But I think now would be a really good time. We're talking about building apps, and what comes with that is maybe having more performance optimization with those apps, especially with compilation. So I'm going to hand it over to 𝗦𝗽𝗲𝗀𝗀𝗀𝗀𝗀𝗀𝗀 We're going to pull up a slide first because he's got some great stuff to show us. But our slides.
Must be the old one.
This is our old slides. We don't have a slide, I'm so sorry. But we're just going to leave this up.
Okay.
You go.
Yeah. So without performance on Windows, when it works right, there's a lot of things that need here. So when you work on performance, you may have heard about the.
Yeah. Can you move your mic up a little higher?
All right. How about now? No. How about if I just hold it?
Do you want my mic?
Works?
Can I hold mine to you?
Okay, it's working now.
Okay.
So if you ever work on, say, performance on Windows, you must have heard about, say, profile-guided optimization called PGO there. The basic idea is just to collect the actual, say, executable running and sample the data, where it goes, which part will be executed, and feed that into the compiler, so that compiler will do a better job about optimizing it when you're spitting out the binary code there. So we've heard, say, good performance number improvements from the PGO, say 5%, 10%. The benefit is very real. But the cost is a little bit hindering the adoption among the ISV like you here. The two major things that we heard about is that, one, it requires some instrumentation, which means some extra code in your app there. You need to do that. Second, when you run that, when you build that, there will be an extra fork in your build pipeline there. And not everyone is a friend about extra things to mess with your build pipeline on that one. And last but not the least, when you run the instrument build, it usually is very slow. So it's not actually mimicking what the end user will see, making the quality of the profile questionable on that one. So this is where the SPGO, the sample-based PGOs, come in to rescue you. So instead of using the app code instrumentation, it's actually using the hardware counters, very lightweight. You can use your release build to actually run that and use the hardware counters to collect the profile, so that you can enjoy the same performance benefit, but without all those friction that we just talked about them. So the impact is really, really real. We work with the Adobe Photoshop team there, and they try it, and they're seeing up to 20% of the improvement in their real workflow, some of the CPU-bound workflow on that one. So in the next few minutes, I'm going to show you how to apply the SPGO end-to-end. Unfortunately, I cannot show that source code from the Photoshop there, so I have to build something myself.
We got Clint as the mic holder. Thanks, Clint.
How about now?
Yeah, nice.
Hey,
Thank you. That's a hero.
Cool. All right, let's put you up. Here we go.
Yep. So on the left, you're seeing a sample code that I'm going to use here. It's just a stack-based virtual machine calculating the Fibonacci series, that one there. You will see all the sample code once we publish the repo on that one, so don't worry about that one. But I want to draw your attention to something here, the switch OP. So this is just running every single operator of your virtual machine stack.
Gotta be the microphone guy. Okay, go.
Okay, so you'll see the switch here, which means it will jump, based on the operator, it will jump from here to there. And as you can imagine, in a stack, actually a lot of the branching can be very predictable, and while the others is rarely used because there's so many loops on that one there. So this is where the PGO and SPGO are really good at, so optimizing. Okay, now let's do it end to end. First step, let's just build it. No fancy thing, no SPGO, just the compiler optimizations for things like that one. And then
Clint's the fourth speaker for our talk, actually.
Yeah.
So
Nice.
I need a favor from you, Kayla. So can you document the runtime here, what the baseline looked like?
I got 3 seconds.
Okay, almost
3
3 seconds there. Okay, that's the baseline. No SPGO, no optimization so far. Now, this is the first step you need to do. It's just to compile your code as you compare the original one and this one here. Everything is the same except there's a /spgo here. So you're not actually optimizing anything yet because you don't have any sample yet, but it's telling the compiler, I'm going to apply spgo. Now prep your executable, PDBs, and everything because you need that information to consume the SPD file later on that one. So just run it. OK, yeah, it comes out say, hey, the SPD is not found too because we haven't fed anything yet. OK, next one, I think many of you are familiar with the xperf, run something, and then xperf again. So this is a traditional way you capture the ETL traces and do a lot of the profiling about that one there. You will see here, there's a lot of numbers and switch or whatever. Don't worry about it now. So you will go, there is a tutorial at the end, you can go and see, hey, what exactly, how it should come in here. But believe me, this is one for the xperf to collect the hardware counters which will be used for the PGO optimization. OK, I'll just run everything here. OK, should be fine. OK, stop the xperf here. One thing, as you may notice, we are just running the release build. There's no instrumentation, nothing fancy. It's just how your end user will actually run your executable here. So that's what we are collecting the data from. Next step, now you have the ETL traces with all the information here. Let's abstract those informations and then put it in an SPD file there so that the compilers can understand what's going on that one. And this is the step 1, and the step 2 here is to actually convert the SPT into the SPD file, which will be directly fed to the compiler. Why don't we just combine these two into one single step? Why have two steps here? The reason is, for a lot of the big software there are many, many important workflows. Some of them are benchmarks, some of the user interaction. There are quite a few things you want to optimize together. So by splitting them into several things like this one, for each xperf, say, capturing the ETL, you can capture one thing. So one workflow for one ETL for one SPD. And you can do several times in parallel. And at the end, you can combine all those SPT signals, information into one single profile data, the SPD, into that one. OK, did I do that now? Yes, SPD here. OK, and this is the last step.
I'm ready for fireworks.
Yeah. More terminal fire.
When does it light on fire?
Yeah.
It's coming. The fire is coming. It's coming. Yeah, I promise you. So when you rebuild with the profile data, everything is exactly the same as you did before, except for the last step here, is that, hey, now I have the profile data at hand. Feed it to the compiler. And again, that's the last step you have here, and then build yet another executable there. How do we know whether it works or not? You can't tell until you run something here. Now, it's optimized build. How long does it take?
2 seconds.
2 seconds, OK. And the original baseline is?
3 seconds.
So without bringing up the calculator, I can tell you it's almost 33% improvement by just running up all these kind of things here. So, of course, your mileage may vary because the app code, the quality of your samples, the hardware, and everything like that one. But we heard reports from the ISVs, somewhere between 5 to 15% of performance improvement by just going through this step here. So you can see what actually really matters. It starts from step 2 here, and then we profile, and then we convert it to SPD, and we build again with the profile data. And that's the whole end-to-end applied to your application. That's how it works here. So we talk about the 20% improvement from Adobe, and they really like it because that means not just the benchmark numbers better, but that's more responsive and out of the way when their users are using the Photoshop on Windows. That one there. Besides the performance number, they also see that this is a rethinking about how they think about optimization there. Previously they did a lot of low-level tunings and doing this and doing that. Yes, they will give you something. But the SPGO jump in and say, hey, this is more a scalable and sustainable way to do that. It's about, hey, this is a whole procedure, and they already very naturally integrate this one into their product build pipeline. Because as you can see, it's not intrusive at all. There's several small things you need to do, but it's not forking an instrument to build or other things, that one. And they see that, and they love that, and they are going to release the SPTO optimized version to the public in the coming days there, so that everyone, the customers on Windows, you'll be able to see the benefit yourself. One more tip that Adobe want to share with all of us, we see, hey, now we have 33%, but is that the end? What happens if I change my code? Because this is a product code. It is a commercial product code. They keep evolving every year there. Even if your code doesn't change at all, your customers may use it differently. Sometimes they use this one, and later they might switch to the other one there. The way to think about the SPTO, this is not a one-shot thing. This is an iterative thing there. You see, you do this one pass here. Oh, the code change, or the customer use pattern changes there. Go back to number 3 here. Run the new scenario, run your new executable, and collect the profile again, refresh your profile, and feed it back to your optimizer. You keep doing that again and again. Again, that could be easily part of your build pipeline already. And this is the way you keep evolving your code and the optimized results as your code evolves and as your user evolves. That one there. So I hope in the past few minutes you agree with me. This is not just a demo. It's reshaping how you think about optimization. It's think about shaping how you think about optimization for the user experience for your customers on that one. And this is also something you can go back home tonight and start applying to your product there, and let us know how it worked for you.
Yeah,
and
totally.
that's the performance story.
Yeah, that's awesome.
Nice.
Yeah, and 33% performance boost on compilation, which is great. And you built your app, then trained a profile on it, and then rebuilt the app with that profile, and that's where that boost came from.
Exactly,
Really
everything
cool.
in 10 seconds. That's how Kayla summarized everything.
That's why your keynote material. Yeah, I see it.
They only gave me 10 seconds. Sweet, that was awesome. Thank you, 𝗦𝗽𝗲𝗀. So I think one of the last things we want to cover, also my app did build, and then it did all the UI testing, and then it finished. So very cool, very cool. Looks like this.
No.
Still not as pretty as Craig's, but you know, what can you do? But actually, speaking of Craig, I'm going to hand it back to him because there's more things with WSL containers that you teased at the beginning that I think we should cover.
Yeah, so let's talk about that API. Kayla, you've inspired me. I want to make my own Mark It Down app that's on Windows as well. And so I want to use an API on Windows. I want to take all that awesome Linux container code that I had and just build it into a Windows app. And I don't want to rewrite everything. So if you take a look on the left side of my screen, I have this great container file. I have all my Linux code sitting here, right? And I've made that as part of a project. So this lives inside of a C# project. And in the C# project, I went to the .cs proj, and let me zoom up a little bit. I've added a WSL containers NuGet package right here. And then I've defined that exact same container that I ran in the CLI earlier. So I said, here's what you want to call it, here's where you can find it, and then here's where I want you to output it. And now, as part of .NET Build and .NET Run, it will automatically build that container. Whenever I edit that, it will just automatically make it part of the build process, so I don't have to think about it. It truly is part of my source code. And I can go and run .NET Run, and it will build and run this app. And so I went ahead and created the same Mark It Down app, but this time I did it fully in WinUI, so it looks nice and modern. And really the big takeaway here while this is building is this looks exactly like a Windows app. In fact, if I didn't tell you that this was running Linux in the back end, you would not know, which is fine. That's great. There are a lot of customers who want to be able to use the power of Linux or don't even know that they need the power of Linux, and they don't want to know about it. For example, my mom and dad don't need to know that they're doing some great Linux stuff in the background. They just need to run powerful apps. So let's take a look at that same receipt that I put in earlier. Well, here we go. It goes in the Windows app and does the exact same rendering, which is pretty great. And so I've made this log here that would show how quickly things start up or shut down. If I go and run this app again, I'll watch that, and you can see the speed that we're starting up that container. It basically takes about 2.5 seconds is how long we're benchmarking from a cold start. And so it's going and initializing the session, and then it will start up the container, and then that's it started, and then now it's running the Linux code inside of it. So then it executed my Python service. And all of this is powered by, if I go to my task manager, I can see that I have a new process here. That mark it down service runs in its own WSL VM. So it's the exact same VM technology that powers your WSL distros. We're now applying it to Linux containers running as part of a Windows application. So each Windows app gets its own WSL VM, and you can run as many containers as you want inside of it. And this wouldn't be a demo without taking a look at the code. So we for sure have to go see how we're actually doing this. And as you can see, it's just some C# code that's not too long. I'm able to go in here and say, hey, please start a new session for me. That starts the virtual machine. And with these CPU and memory count. And then I can start that. I can pull a specific image. In this case, I'm running that locally. And where it's really powerful is I can configure this to have exactly what options I need. So in this case, I said I want only port 8000 to be mapped over, so that I'm exposing that API that I used before. And you can add other options here, like you can do volume mounting, for example, to say, hey, I want to be able to run or access only specific Windows folders. Or you can even do things like, hey, I want to give this access to my GPU. And so super powerful way that runs. And when it's all closed and done, all of those resources are cleaned up. You can see the VM has gone away. And so it works just like any other app. And the last thing I'd want to show is we're also improving the ecosystem. So we're really trying to make this a very comprehensive end-to-end story of developing with containers wherever you are, API or CLI. So we're doing fun things like if you go to, there's a project Lazy WSLC, you can get a very nice TUI demo or TUI interface for all of your containers. So you can go ahead and take this as a nice dashboard. On top of that, this will also be supported with dev containers. So if you do commands like attach to running container, reopening container, or use it in VS Code, WSL container will be supported there as well. And then last but not least for our WSL container demos, we also wanted to highlight an amazing partner that we've been working with. So we've been working with the 𝗦𝗽𝗀 team. They're a team that builds a super powerful Linux-based rendering engine, and that is used to render tons of movies that you might be aware of, like The Bad Guys 2 or The Wild Robot, which I'm a big fan of, as I love robots. And so this is a team that has all of their code in Linux and is open source, fully open source, just like WSL. And they want to bring this awesome tool to Windows users to easily use. Well, how do you bridge that gap and make it production ready? That's where we've been able to work together on taking a look at the Windows subsystem for Linux containers. And so I can go ahead and take a quick look here. I have a demo app of their code. So I have the WSLC 𝗦𝗽𝗀 folder. And I have built this and created 𝗦𝗽𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 inputs to this. And if you note the backslash, these are definitely Windows files that I am giving in. And these are Windows files of .rdla, which are basically render inputs. And then I'm asking it, hey, could you please render out this JPEG for me? And when I run this, it's going to run exactly the same as what I showed earlier, just a command line version. And I've shown that I've kept in this like debug information here. So you can see that was the machine starting. Now we have the actual rendering happening. It's using up all of my CPU, which is exactly what you want to see when you're doing a nice render. And then once it's done, it will perfectly shut down, clean up the VM. And I can go ahead and take a look at the beautiful image we rendered, which was this lovely orange coffee maker. And so that was all done exactly as a Windows CLI, right? It's .exe. It was all Windows inputs and outputs. I opened a Windows file, but everything, all of the code that was running in the back end, beyond just the integration code for the API, was fully Linux. So something we're really, really excited to see what you could do with, from AI containers, AI containerization, to cloud to local. I think there's tons of exciting opportunities.
Cool. Sweet. Yeah, that was great. And we're running out of time here, so I'm going to kind of wrap it up with one last note. So we, on our team, we've been working on all these open source tools, and we've been working on open source for years. And actually, Clint had the great idea of exporting the list of contributors, of everyone who's contributed to Terminal, WSL, WinUI, PowerToys, and the file is 16,000 lines long. So we've had over 16,000 open source contributors on all of our projects, which is huge. So we want to truly, truly thank everybody that's contributed to everything that we've been working on, because the products would not be where they are today without y'all.
I should have my name ZZZZZZ so I show up.
Yeah, you should have been. Yeah.
I should have.
Come on, Craig.
Wasted opportunity.
And of course, we're very excited about Core Utils. So we thought it'd be fun to do a little grep with one of our friends, 𝗦𝗲𝗀, who's been a really awesome contributor, and especially for PowerToys. So want to give a huge shout out to our contributors and 𝗦𝗲𝗀 as well. But we want to just thank everyone who's made these products, shape up to where they are today. So here's that slide with all the links that I told you about. So we're gonna maybe recap a little bit, but we talked about config file. We had that comfort shell in that same repo. SPGO that 𝗦𝗽𝗀𝗀𝗀 covered. This link will show you how to run that with your own projects and get that performance boost with compilation. And then, of course, there's Intelligent Terminal and its own repo. The WinApp CLI and WinDevSkills have their own repos, and PowerToys also has its own repo. So if you want to get started with any of these, this is the slide to grab. And with that, we can jump into Q&A. Thank you so much, everybody, for listening and watching, and feel free to scan this because I think it's important. So thank you, everybody, and we're happy to answer any questions.
Thank you.